Good morning, Year 6. Today we're going to move on to a new maths topic of ratio and proportion. So before we do anything else, please make sure you have a piece of paper and a pencil. I'm going to ask that everybody make sure they're completing their maths work on paper from now on. You need to show all of your calculations and you can't do that on the computer. All right, so without further ado, let's get started. What I'm going to ask everybody to do is pause the video now and have a go at answering these 6 arithmetic questions. Please pause the video and have a go at these 6 arithmetic questions. Okay, I'm going to start going through the answers now. Make sure you've answered all 6 questions with all of your working out. For most of them, I'm just going to simply give you the answer, but I do want to spend a little bit more time on question 3. Question 3 is a multiplication of fractions. There's 2 ways really that would have been sensible in order to solve this. Firstly, making 10 over 1. Then you're doing 3 times 10, which is 30, and 5 times 1, which is equal to 5. If you did this method, however, please make sure you remember you can't leave your answer when you're timesing fractions. It's only for timesing fractions. You can't leave your answer as a top-heavy fraction. So all you need to do now is simplify that. 30 divided by 5 is equal to 6. The other method that I think would have been sensible is to view it instead of 3/5 times, to think of it as 3/5 of 10. If you're doing that, all you need to do is 10 divided by 5, which is 2, times that by 3, equal to 6. Both correct ways of solving it, so long as you get the answer 6. Okay, you're now going to have a go at these reasoning questions. In these reasoning questions, you have a bar graph showing 6 classes at Winwood Primary School, split into their 6 classes, and then within those classes split into girls and boys, and you're finding out how much money was collected in pounds. Please pause the video and have a go at answering those 3 reasoning questions about this bar chart. Okay, I'm going to start going through the answers now, so make sure you've had a go at answering all 3 of those reasoning questions. For question 1, how much did the boys in class 4 collect? Go to class 4, check the key for boys. Here is boys in between 4 and 6, so that's equal to £5. Don't forget your unit of measure. How much more, and we know that phrase how much more means subtract, did the boys collect than the girls in class 5? Go to class 5, we see that the boys collected in between 16 and 18, which is 17. And the girls collected down here 14. 17 subtract 14 is equal to 3. And then don't forget your unit of measure for this question is pounds. Okay, how much money did the class 3 children collect in total? We know in total means we're adding. So I go to class 3 and I add together 18 and 14, which is 32. And then don't forget the final step is to make sure you've got your unit of measure here, which is pounds. 32 pounds. Well done if you confidently answered all of those questions on statistics. It's something we'll keep on revisiting and reviewing as we're going through the rest of the year. We're going to move on now to today's main content. Today, we are learning to express relationship between 2 different quantities using ratio. You'll do now is to revise your ability to express relationship between 2 quantities using fractions, though. So the question 1 says, what fraction of these circles are green? Think about what your numerator and denominator would be, and what fraction of the circles are blue for the bottom question. Please can you pause the video now and have a go at writing the date, the WALT and answering both do now questions. I'm going to go through the answers now. Make sure you've paused the video, written the date and WALT and done the do now questions. So first you need to know what the denominator is. The denominator is the number on the bottom of the fraction that tells you how many equal parts there are. 1, 2, 3, 4, 5, 6, 7. There are 7 circles, so there are 7 equal parts. The numerator is the number on the top and that tells me how many you're referring to. We're counting the green ones, so that's 1, 2, 3, 4, 5. 5/7 are green in the first diagram. Let's go down to the second diagram then, and you can count them again and find that there are 7 circles. And this time we want to know how many of them are blue. 1, 2, 3, 4. 4/7 of these circles are blue. Well done if you were able to do that. That's going to be part of the knowledge we're revising today. Okay, ratio. Ratio is the relationship between 2 or more different quantities where that remains the same throughout. For example, let's look at this first pattern. For every 2 green circles, 1, 2, there is 1 blue circle. That means if I were to continue the pattern, I would have to draw 2 green, and every time I draw 2 green, I have to stop and draw 1 blue. I could also do it the other way around. Every time I draw 1 blue, I have to stop and I have to draw 2 green ones. Oops, that's not green. So each time you're making sure the relationship between the green and the blue remains the same. Let's have a look at the ratio for the next 2 then. For every green circles, there are blue circles. So how many green circles are there for every how many blue circles? Think about what you would say. There is 1 green circle for every 3 blue circles. Now, let's have a look at the bottom one. We've got the same sentence, but a slightly different pattern. It's in a different order, but how many green circles are there and how many blue circles are there? It's actually exactly the same ratio, 1 green for every 3 blue. So it doesn't matter what order they're in, you just need to have the right amount, the right quantities, 1 green for every 3 blue. Let's have a look at these questions then. So complete the sentences. For every 2 blue flowers, there are pink flowers. 1, 2 blue. Well, how many pink? 1, 2, 3, 4. For every 2 blue flowers, there are 4 pink flowers. The next sentence, though, says for every blue flower, there are pink flowers. I now only want every 1 blue flower. So I look at my pattern and I stop before I get to the next blue one. Having a look here then, if I want just 1 more blue flower, how many pink flowers will I need to draw? Well done if you're thinking 2. Right, we're going to start now looking at these questions, and these question types are just like what you're going to do in your independent work and for your practice questions. We're going to start by asking what fraction is a colour, and then we'll express it as a ratio. So firstly, what fraction of these shapes are blue? In order to find the fraction first, count the total number of shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 shapes in total, so the denominator is 10. How many of them were blue? 1, 2, 3, 4. 4/10 of this shape are blue. What fraction's yellow? I don't need to recount the denominator, it's still 10 shapes. It's the numerator that will change now. If 4 of them were blue, how many are yellow? You could either count them or say, well, it's the rest of them. There are 10 in total, 4 are blue, so 6 must be yellow. Now, we move on to how to write a ratio. When you're writing a ratio, the order is incredibly important. This question says, what is the ratio of blue to yellow? Okay, now when you're reading the ratio, you must make sure you're doing it in that order. When you see blue, underneath blue, you're going to say how many blue shapes there are. So there are 4 blue shapes. The 2 mathematically is represented using a colon. That means for every blue shape, there will be how many yellows? 1, 2, 3, 4, 5, 6. 4, 2, 6. That ratio can actually also be written the other way around. If the question asks me what ratio is it from yellow to blue? If I was asked that question, it's a different answer. It's 6 yellow to every 4 blue. In ratio, it's essential that you get the order the correct way round. For example, if I was asking you to make a glass of squash and I said put in 1 part squash for every 3 parts water, if you did that the other way round, we'd have a very, very, very strong glass of squash. So make sure when you're reading your ratios, you're paying attention to which way round your order's going. Okay, let's have a go at this one then. What fraction of these shapes are blue? The denominator will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many of them are blue? 1, 2, 3, 4, 5, 6. 6/12 are blue. How many 12ths will be red then? If 6/12 are blue, how many are red? Well done if you're thinking 6. Bonus question. These fractions are equivalent to what? What's the simplified version of 6/12? Quickly work it out now. Well done if you're thinking 1/2. Okay, what is the ratio of blue to red counters? There were 6 blue to every 6 red counters. And for this next question, again, 6 red counters to every 6 blue counters. So you can see actually half of these counters were blue and half were red, and that's actually represented as the number being the same. Equally, if I had the ratio 1 to 1, that would mean 1 triangle for 1 circle, 1 triangle, 1 circle. That's half. 2 to 2, 3 to 3, 4 to 4. All of those would be equivalent to half of the shapes being that colour. Right, it's over to you. You're going to have a go at your first independent or input questions. I'm going to ask you to pause the video and try and answer all 3 of these questions. Make sure when you're doing the ratio, you pay attention to the order you're being asked to answer it in. Pause the video and have a go. Right, we're going to go through them then. Make sure you've had a go at answering these questions by yourself first. First, what fraction is green? There are 15 shapes in total and 3 of them were green. Again, there are still 15 shapes, but this time I'm counting the yellow ones, which was 12. Now for my ratio, I want green to yellow. It has to be the right way round. How many are green? 3. How many are yellow? 12. If you want to check that you've got your ratio correct, you can also check it like this. Add 3 greens, add 12 yellows is 15 shapes in total. Did we have 15 shapes in total? Yes, we did. Okay, that's correct. Right, what about if there's 3 different values? It doesn't really change how we do our fraction. There are still 6 shapes in total, and what fraction of them are blue? 1, 2, 2/6 are blue. Similarly, what fraction are green? Well, there's still 6 shapes. How many of them are green? 3/6. Equally, when we're doing our ratio, it doesn't really change much at all. What's the relationship or ratio of blue to green to red? All this means is I'm going to have 3 numbers instead of 2 of them. How many are blue? 2. How many are green? 3. And how many are red? 1. You'll notice it's not the order the shapes are drawn in, it's the order the question is written in. The shapes go in the order green, blue, red, but my answer must be in the way it's written. Blue to green to red. 2 to 3 to 1. To double check that's right, let's add it up and see if we've got the right number of shapes. 2 add 3 is 5, add 1 is 6. Yes, there are 6 shapes. Okay, you're going to have a go at a question just like that then. Pause the video and have a go at this question, just like the one before, so if you need to go back and rewatch it. Okay, we're going to go through the answers now. You should have answered all 3 of these questions. What fraction of these shapes are blue? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 shapes in total, and 4 are blue. 4/9 are blue. What fraction are red? There's still 9 shapes, but this time 2 are red. Finally, your ratio, red, which is 2, to green, which is 3, to blue, which is 4. If your order went in a different order, you actually got that question wrong. It must be red to green to blue. 2, 3, 4. If we added that all up, it would be equal to 9, telling us we've got the amount correct. You can also be asked to simplify a ratio. For example, here, my ratio is 2 yellow counters for 4 blue counters. Every time I lay down 2 yellow counters, I must also lay down 4 blue ones. But what if I only have 1 yellow counter to lay down and I still want to put it down? If I've just got 1 yellow counter, how many blues will it be? Well, let's go through how you would solve that. It's actually exactly like when you're finding an equivalent fraction. The rule is, with equivalent fractions, whatever you do to the numerator, you must also do to the denominator. When you're trying to simplify a fraction, you have to find the highest common factor. What number is in both the 3 and the 9 times tables? 1, yes, but 1's in every times table. 2, no. 3, yes. Okay, 3 is the highest common factor. 3 divided by 3 is 1, and 9 divided by 3 is equal to 3. I've divided both the numerator and the denominator by 3, and that's exactly what you do with a ratio. My ratio of yellow to blue is 2 to 4. What number goes into both 2 and 4? I can divide both by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. My ratio now says 1 to 2. That means if I can only draw 1 yellow counter, I must draw 2 blue counters to accompany it. Is 1 to 2 the same as a half? If we look just down here, if we look just down here at my yellow and blue counters, I've drawn 1 yellow counter for 2 blue counters. Would that be considered the same as half of them? No, it wouldn't. A fraction is written 1/2, but that doesn't mean as a ratio 1 to 2 is the same. 1 to 2 means there are 3 parts in total. The first bit is a third and the second bit is 2/3. Moving on then. What's the ratio of blue to yellow? So first you start by doing your simple ratio. There are 4 blue, make sure you get the order right. Blue, 4, yellow is 6. Now what can I divide both of those numbers by? Have a think. And the answer is 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. The simplified ratio is 2 to 3. Okay, how about when we've got a question with some drawings of some fish? What is the ratio of grey to green? You've got to start by counting the grey. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There were 12 grey fish. I put that first because in the question it said grey to green. Now count the green. 1, 2, 3. 12 to 3. What can I divide both of those numbers by? What's my highest common factor? Have a think now. Have a go at simplifying it in your head. You don't need to write it down. I'm going to divide both by 3. Well done. So that'd be 4 to 3. My simplified ratio is 4 to 3. It's time for you to have a go now at question 7 and 8. For question 7, the ratio of blue to red. Question 8, simplify that ratio. Pause the video now and have a go at those 2 questions. Right, I'm going to go through those 2 questions. Make sure you've had a go at them by yourself first. How many blue fish are there? 1, 2, 3, 4, 5, 6. 6 blue. How many red? 4. When you simplified that, divide them both by 2, your simplified ratio would have been 3 to 2. If you said 4 to 6, you've got it wrong. You have to start with the right colour. So well done everyone who got that right. I'm now going to go through your independent work. At this point, you can choose to go and look at the work on the task sheet, or you can continue watching the video. I would recommend watching the video because the questions are all in the same place, and I'll go through the answers at the end, and you don't need to flick between anything. You don't need to draw anything or have anything to draw on. You don't need the task sheet at all, so please feel free to just continue watching the video where all the questions will be displayed, and I'll be able to give you some tips. So for these first 4 questions, they're just like what we've practiced. Pause the video and have a go at these first 4 questions, making sure you're doing it in the right order, blue to pink. Okay, make sure you've done those 4 questions because I'm going to move on to the next 4. There are 5 questions here, sorry. Question 5 to 8 are exactly the same. Question 9, though, is asking you to draw your own pattern. So draw your own pattern with the ratio 4 triangles to 2 squares. Have a go at those 5 questions. Pause in the video if you need to. Well, you need to. Pause the video and then I'm going to go on to the next group of questions. So make sure you have a go. Okay, for these ones then, you're going to have to write 2 different ratios for each number. We're moving on to simplifying ratios now. So simplifying ratios question 1, first you would write your ratio of red to blue as you have there. What is the initial ratio of red to blue? Then underneath you're going to simplify it by dividing both. So your new numbers would go there and there. For each of these you have 2 different ratios. Pause the video and try these 4 questions. Okay, for the next group of questions, you simply have the numbers and you just need to simplify them. You've already got the ratios written out, now simplify them. For question 7 and question 8, you're looking for the highest common factor of all 3 numbers. You can do this, is what you've practiced before with fractions. Pause the video and try these 4 questions. Okay, and here are the reasoning questions. I would like everyone to have a go at least one of the reasoning questions. I'm going to go through them in order for you and give you some tips. I would say that this question here is probably the easiest reasoning question. So if you're only going to do one, start with this one. And I would also recommend drawing a diagram to help you explain your thinking. This is the next reasoning question here, and you're being asked if these statements are true or false. Again, I would recommend writing out your ratio red to blue, and start with the ratio shown in the picture. 2 red to every 8 blue. You're basically then deciding if these statements are true. Are they equivalent ratios? It says for every 1 red cube, there would be 8 blue cubes. 1 red, 8 blue. Is that an equivalent ratio? If it isn't, then that's wrong. If it is, then it's correct. Finally, this last one here. Whitley lays the tiles in the following pattern. Red, red, yellow, yellow, yellow. Red, red, yellow, yellow, yellow. If she has 16 red tiles and 20 yellow tiles remaining, can she continue her pattern without there being any tiles left over? Yes or no, and explain why. For this one, you could either choose to express it as a ratio and explain it that way, or you could try drawing the pattern with red and yellow tiles. But remember, she's only got 16 red and 20 yellow, and it must follow the pattern red, red, yellow, yellow, yellow. Have a go at least one of those reasoning questions, please. Right, I'm going to go through the answers now, so make sure you've completed all of the independent work and you're ready with a different coloured pen in order to mark your work. Right, so the answers to the first 8 questions have just been written up there. Obviously, what 3/7 is 3/7 written as a fraction. For number 9, really, there's so many different ways you could have represented that one, so we can't really mark it together, but just upload it onto Seesaw so that your teacher can have a look at it. For your next group of questions, these are the 4 different sets of ratio. Remember, you need the initial ratio and then the simplified ratio in order to get this one correct. Pause the video if you need to in order to mark. For your next group of questions, you have got the simplified ratios at the top. For question 5, you are dividing by 4, dividing by 3, dividing by 7, and dividing by 5 for the last one. I'm not actually going to go through the answers to the reasoning questions because I'm really interested in seeing what you do yourselves and the thinking that you do. Remember, I've said everyone needs to try at least one of those reasoning questions. I don't mind if you find it tricky or if it's difficult. Just make sure you try at least one of the reasoning questions. Okay, well done to everyone who tried so hard today. Please don't forget to upload your work onto Seesaw. I can't wait to see it.